Let's recap what we need to know to prove triangles congruent by angle side angle. We need to find two angles and the included side. To prove triangles congruent by angle side, you need two angles and a non-included side. Let's look at example 2, where we're going to do another proof. Step 1, SQ bisects angles RQT and angle RST. And that's given. We should always go and mark what we know based on that information. So because RQT is being bisected, we know that those two pieces will be congruent, and we know that RST is being bisected, so that makes those two angles congruent. We need to state that in our proof. So we're going to say that angle RQS is congruent to angle TQS. And our reason is definition of an angle bisector. You can write out the word angle if you'd like, but I'm trying to keep it simple here. Go ahead and write out the other two, which is RSQ being congruent to angle TSQ. And this is also definition of angle bisectors. The next thing we know is that QS is going to be congruent to SQ. And the reason for that is the reflexive property. Now we have enough information to prove that our triangles are congruent. We can say that triangle QRS is congruent to triangle QTS, and the reason we know that is by angle side angle congruency theorem. Some abbreviations there to keep it simple. Let's do another one. Start off with our given information, which tells us that JK is parallel to LM and JL is parallel to KM. And that is given information. So I can mark that that is parallel to that, and that this side is parallel to this side. Our goal is to prove that these triangles are congruent. The first thing that I see really easy to prove here is that KL is congruent to LK. And the reason that that is congruent is because of the reflexive property. I'm going to go back to what my given information was and talk about the fact that JL, or JK is parallel to LM. That was the first thing that they gave me. So JK being parallel to LM makes this right here the transversal. And that means that this angle and this angle are going to be congruent. So I need to make sure that I name those correctly. I'm going to say the angle MLK is congruent to angle JKL. This is K right here, and this is J right there, in case you can't see that. And the reason that those are congruent is that they are alternate interior angles. There. That is the reason we can state that those are congruent. Now we're going to look at the other two parallel lines that were given to us being cut by that same transversal. This time we're going to be able to determine that this angle and this angle are congruent. So I'm going to say that angle JLK is congruent to angle MKL. And again, that is an alternate interior angles theorem. I now have enough information to prove that the triangles are congruent. And I can say that triangle JKL is congruent to triangle MLK, and the reason is angle side angle congruency theorem. Go ahead and pause your video, do the try it, and return to check your answers. Start by filling in the given and marking the information that you know on your picture. From the information given, with AC being the midpoint of AE, I know that AE is cut into two equal pieces. So I can say that AC is congruent to EC, and that is the definition of a midpoint. I also know that these two angles are congruent. So I'm going to carefully name them BCA. And remembering that order is important. If I started at B, I'm going to start at DCE. And the reason that we know that those are congruent is because they are vertical angles. We now have enough information to prove that our triangles are congruent. Triangle ABC is congruent to triangle EDC, and that is by the angle side angle congruency theorem.